we're given the CDF of a continuous random variable x, and we're asked to determine some probabilities for that continuous random variable x. For this, before we actually proceed with this, we need to recall something. So let us recall. In general, to answer probability questions of continuous random variables, we're talking about specifically continuous random variables. So probability questions of continuous random variables, so CRV is continuous random variable, we can use either PDF or CDF, right? We can use either. To answer probability questions related to them, given the information available to us, we can use either PDF or CDF. We know if we have one, we can go to the other as well, but depending upon whatever is more convenient, you can use either. How do we use the PDF? Remember, we integrate PDF because recall, like we said, the area under PDF gives us probability. And we can find the area under a curve using integration. So we integrate the PDF over an interval. We find the probability that continuous random variable lies in that interval. Or we can use the CDF as well. So use expression of CDF. Use expression of CDF, where we know the CDF for a continuous random variable x is f capital F of small x. This is written as probability x is less than equal to x, which can also be written as the probability x is less than x. Right? Why does this work? Because remember, in general, the CDF definition is this. It's the probability x is less than equal to x. But for the continuous random variable x, we can also write it as probability capital X is less than small x. Because for a continuous random variable x, the probability that capital X is equal to the value small x is equal to 0. So the probability that x is less than equal to x is the same as the probability x is less than x. We know for continuous random variable, the probability that it equals some specific value by probability capital X is equal to the specific value small x is equal to 0 because it takes a continuum of values. So the probability it takes on any exact value is always 0 for a continuous random variable, right? Like equal to sign does not matter for continuous random variables. Equal to sign does not matter for continuous random variables, but it does matter for discrete random variables, right? In discrete random variables, we do have to be careful about the equal to sign. But for continuous random variables, the equal to sign does not matter, right? So whether you're asked to find the probability x is greater than 1.8 is the same as the probability x is less than equal to 1.8, right? The both are equal. Whether you're asked to find the probability x is greater than minus 1.5, it's the same as probability x is greater than equal to minus 1.5. They're the same. The equal to sign does not matter for a continuous random variable. Similarly, whether you're asked to find the probability x is greater than minus 1, less than 1, this is the same as probability x is greater than equal to minus 1, less than 1. Probability x is greater than minus 1, less than equal to 1. Probability x is greater than equal to minus 1, less than equal to 1. They're all the same thing. They're all same thing for a continuous random variable, right? Equal to sign does not matter. All same thing for a continuous random variable x. Equal to sign does not matter. Right, so just keep in mind whenever you're solving probability questions for a continuous random variable, equal to sign does not matter. You don't have to care about whether you have an equal to sign or not, which is something that we do have to be careful about with discrete random variables, right? So this is something key to remember. And its CDF cannot just be written as probability x less than equal to x, which is the definition of CDF, but because the equal to sign does not matter, the CDF can also be written as probability capital X is less than small x, but this is only true for continuous random variables and not discrete random variables. Because in discrete random variables, we know the probability that capital X is equal to X is not always 0, right? Because depending upon what values the discrete random variable takes, the probability that's equal to a specific value will be non-zero, right? So for a continuous random variable, probability X is always 0, but that's not true for a discrete random variable. So here it doesn't really matter whether this question was probability x is less than 1.8 or x is less than equal to 1.8. Whether this was probability x is greater than minus 1.5 or probability x is greater than equal to minus 1.5, it doesn't matter. Similarly, this could be expressed in all these three ways and the answer would be the same. So just keep in mind for continuous random variable, we don't have to worry about the equal to sign. For discrete, we do have to look into it. Let's actually solve this question. So we could have solved these probabilities using the PDF, but here what we're going to do is we're going to solve these probabilities using the CDF. So you can use either PDF or CDF to solve probability questions for continuous random variable, depending upon whatever is more easier to use and what information is available. Although you could find PDF from CDF and CDF from PDF, but here because we're given the CDF, so let's just directly use that instead of first finding the PDF. Although we could have done that. We could have first found the PDF and then integrated it over the relevant intervals to find these probabilities. But here we want to look at how we can answer this probability question using the CDF, which is already given to us. So we want to find the probability x is less than 1.8. Now we know okay, this is equal to f 1.8. Right, like we said, we can either integrate the PDF to find probabilities of continuous random variable, or we can use the expression for the CDF. Here we learn how do we use the expression for the CDF. So this is essentially the definition of, here we just applied the definition of CDF, which we know is just given to us as fx. We know in general, fx is just equal to probability x is less than equal to x. But for a continuous random variable x, we know the equal to sign does not matter because the probability that capital X is equal to small x is 0. This is just the probability x is less than x for continuous random variable x. This is true always. This is true when it's a continuous random variable. This won't be the definition of CDF for a discrete random variable. So just apply the definition of the CDF. Again, it doesn't matter whether this is less than or less than equal to, because we're continuous random variable, the equal to sign does not matter. So probability x is less than 1.8 is just f1.8. So we want to find the value of the CDF at the x value 1.8. So 1.8 falls in this interval when x is between -2 and 2. So 1.8 falls in this interval, so use expression CDF. We know for x values between -2 and 2, the CDF expression is this, 0.25x. Here x is 1.8 plus 0.5. So this is just 0.95. So this is part A. Now let's do part B. So part B is the probability x is greater than -1.5. Again, it doesn't matter, it's greater than -1.5 or greater than equal to -1.5, the equal to sign does not matter. First, because you want to use the CDF to answer this, what I'm going to do is I'm going to use the complement rule and rewrite this. Right, because you want to use the CDF to answer this probability question, and the CDF, we know by definition, is of this form, right? Probability x is less than x, which is equal to probability x is less than x only for a continuous random variable x, obviously. Right, so we want the probability instead of in greater than form, we want the probability to be greater than less than equal to form, and for this we use the complement rule, right? You know, the complement rule tells us, so the complement rule is the probability of A is 1 minus probability not A. Right? So basically the probability x is greater than 1.5 is 1 minus probability x is less than equal to minus 1.5, right? So helps us to rewrite. So what the complement rule does, it is helps us to rewrite probability x is greater than minus 1.5 in terms of the CDF of x. In terms of CDF of x, which is probability x is less than equal to, because now we can apply the definition of the CDF because now it's in the form of the CDF, right? X is, which is like f minus 1.5, right? So we're using the complement rule here because this will help, because we want to use the CDF to answer this probability question. So we want to rewrite this probability first using the complement rule in terms of the CDF of x. So now what we can do is we can write this as 1 minus f minus 1.5. So we're just using the definition of the CDF here. So we're applying the definition of CDF here, where we know f of x is probability x is less than equal to x, right? So f of minus 1.5 is just the probability x is less than equal to minus 1.5. So we know minus 1.5 again falls in this interval. We know this is the CDF evaluated for different values of x. So here 1.5 minus 1.5 falls in this interval, right? So again, I'm going to evaluate, we're going to use, so we know for values of x between -2 and 2, this is the expression of CDF that we're going to use. So what we're going to do is, so we have a 0.25 and the value of x that we're looking at is -1.5 plus 0.5. And this is going to turn out to be, and just simply, it's going to turn out to be 0.875. Now the last part, part C. We want to find the probability that x is between -1 less than 1. Again, it doesn't matter if this was probability x is greater than equal to -1 less than 1. Probability x is greater than -1 less than equal to 1. Probability x is greater than equal to -1 and less than equal to 1. It does not matter. For continuous random variable, the equal to sign does not matter. So we can rewrite this probability that x is between -1 and 1 as the probability x is less than 1 minus the probability x is less than equal to -1. Again, we could write, even if you write this as probability x is less than equal to 1 or x is less than -1, it won't matter for continuous random variable. The equal to sign makes no difference. Probability x is greater than -1 less than 1. We can just write it as a probability x is less than 1 minus the probability x is less than equal to -1. Now we'll just apply the definition of the CDF. We know probability x is less than 1 is F1. Probability x is less than equal to -1 is F minus 1, right? Again, we're applying the definition of a CDF, but again, equal to sign does not matter. It's a continuous random variable, right? Remember our definition of CDF, this is probability x is less than equal to x is probability x is less than x1. But this comes only from the fact that it's a continuous random variable, right? So the equal to sign does not matter. So apply the definition of a CDF. So now, so we want to, this is, we know, f of x, and we want to find it evaluated at x is equal to 1. 1 falls in this interval. So this would be 0.251 plus 0.5. We want to now evaluate the CDF at x minus 1. Minus 1 also falls in this interval. So 0.25 minus 1 plus 0.5. And then we can just solve this, and this turns out to be 0.5. So in this way, we looked at whenever you want to answer probability questions related to continuous random variable, you can either use the PDF, where you can integrate the PDF over the relevant interval to find the probability the continuous random variable lies in that interval. Or you can simply use the expression for the CDF given to you, and we can answer any probability question related to it. When using the CDF, just keep in mind, okay, we know the CDF in general is this, right? Probability x is less than equal to x. But for a continuous random variable, because the probability capital X is equal to a specific value small x is 0, point probabilities are 0, equal to sign does not matter. So this can be just probability x is less than x. This is only for continuous random variable, right? For discrete random variable, probability x is less than equal to x won't be the same as probability a capital X is less than x. Right, so for continuous random variable, we don't have to worry about the equal to sign when finding probabilities, because the probability is equal to some specific value is always 0.